All right, in this practice problem, we're going to try to find the pressure inside our bottle after it's been heated up. So you had a metal, raw steel water bottle, and it was 3/4 of a liter in volume. You drank a whole bunch of it, and there's 125 mils of water left in the bottle. You seal it up, and you put it in your car, and you let it get hot. And so in car, it goes up to 50 degrees Celsius. I'll tell you that the vapor pressure of water at 50 degrees Celsius is equal to 92.5 torr. So your bottle just bakes inside your car in the sun. It's summer, and so it gets very hot. Well, first thing first, take a minute and just think of all the parts that are going to change. What are all the things we need to solve for this? If our goal is to find final pressure in car, if I want to know what the final pressure is after it gets heated up, how am I going to do that? Take a second, try and solve how we do it. Come on back and we'll talk through the ideas and then give you a chance to run the values. All right, if you're back, well, let's think about a couple things. I've got some gas. There's air in here already. And so there's already some gas. So on the one hand, if I want to know what's going on at my pressure final, well, it's going to be the pressure of the air plus the vapor pressure. Vapor pressure was told to us, but I need to deal with the pressure of the air. To know that, well, I need the pressure of the air final. That air starts at 22 degrees Celsius, but it goes up while it sits inside that can in the car. It goes up to 50. And so there's going to be some final pressure of the air. So I'm going to have to solve what the pressure of the air is at the end. Which means I need some moles, I need some volumes, I need some temperatures. So our problem here really is to find how does that pressure of the air change. Go ahead, give that a try, see if you can solve our total final pressure. All right, if you're back, well, let's think about our air. Let's do air in green. So the air, I need some PV equals nRT data. I know what my final temp's going to be. It's going to be 50. But I need to know what's in the bottle to start with. Depending on how we want to do it, we could plug in our starting pressure. When you seal up the bottle, it's going to be at just whatever the atmosphere was outside. Volume. Do we know volume? Well, sort of. We know the size of the container, but there's water in it. The air is only in this section of it. And so we'd have to find the difference there, but we can solve that. 750 minus 125, so 625. So 0.625 liters. That is the air space. Notice how much space is left that isn't the liquid. So I do know my volume, I know my starting temp, I could find my moles. But the air is not escaping. Moles is going to be the same in both problems. Remember your pressure 1, your volume 1, N1, T1 must equal R, which must equal pressure 2, volume 2, moles 2, and temp 2. If my moles are going to be the same, they just cancel out. My volume, probably going to be basically identical. I might lose a little water into gas, but the water is also going to expand. It's not a huge temp change. Probably our volume is not really altering either. So really what I have is I have a pressure, and I have a temperature, and I have a pressure and a temperature. I can solve the final pressure of my air just by pressure 2 must equal pressure 1 temp 2 over temp 1. Now I'll need them in Kelvin, but if I multiply all these together, 1 atmosphere, temp 2 at 50 Celsius will be 323 Kelvin. At 22 degrees Celsius, it'll be 295 Kelvin. So pressure 2, the final pressure of my air, 1.095 atmospheres. Which, if we want to turn into torr, 1 ATM is 760 torr. So this is 832 torr. Since our vapor pressures are in torr, it helps to be in torr. Well, that means my pressure total is going to equal 832 torr from the gas that was already there, plus 92.5 torr from the water vapor. Since our water vapor, since that pressure is based on temperature, there's no adjustment needed. That is just what it is at this temperature. And so our total then becomes 924.5 torr. Well, that's quite a bit more than when the bottle was sealed up. The bottle was sealed at 760, so 1 atmosphere. We have increased this by 160, a rather large percentage. And so when you go and open that bottle later, if you've ever had a hot bottle spray out a bunch of liquid and gas when you first open it, this is what's going on. It has increased the pressure because both the gas and the vapor pressure have changed.